These here are 3D printed surfboard fins, and so are these, and so is this. That were printed on this, the Bambu Lab X1 Carbon 3D printer. Hey, how's it going, guys? In this video, I'm going to talk about my experience with the X1C 3D printer. I've been using this printer for several weeks now, and so for some context and history, I'm not a 3D printing channel, but I have reviewed, a few 3D printers in the past. So during the race to the bottom of the 3D printing revolution, I got so many requests to review 3D printers from startup companies that I think found my reviews, and some of them were pretty popular. So now you might think, I get a free 3D printer and all I have to do is a review, but actually, it is a ton of work to do a review just for a quote-unquote free printer. I already have enough 3D printers, so yeah, I turned them all down. So how is that relevant for this here, the X1C? Well, Bambu Labs reached out last winter asking if they could ship me their flagship printer, the X1C, to use in my projects. And again, I really wasn't that interested. Since that time though, I hear how Bambu Labs have been like a disruptor in the 3D printing space. But the actual reason why I have one of these printers now is because a friend of mine purchased a P1S with the AMS system and is blown away by the quality and the speed of the printer. He said I had to check out the Bambu printers, and even Adam Savage of Mythbusters fame has a couple of these printers. So with those glowing reviews, I reached out to Bambu Labs to see if they were open to still sending me a printer, and within a few days of reaching out, a huge box was delivered to my door containing said printer. They have no expectation for me to post anything about this printer. They provided it for me to use for my projects, but I figured, hey, since I'm already trying it out, it would make for good contents anyway, so here we are. So I'm not going to go over every little technical detail about this printer. I'll just talk about the things that stood out to me. So the setup only took about 30 minutes, and after that, I was off and printing. The unboxing experience is, well, how can I put it? Something you would find from Apple. So Bambu really is aiming to make the user experience as best as possible. As well as the user experience is particularly good with the software, the app, or on-screen display, giving prompts when something needs to be addressed, such as if you have the wrong type of print bed on the printer, it'll throw you an error and let you know, or if the lead screws, say, need grease, which when I first turned it on, it did. The colorful display can also provide instructions when you need to do something such as loading and unloading filament. And it even prompts you with a QR code that you can scan with your smartphone to get additional instructions. That's kind of a nice touch. Also, I think the printer looks, well, beautiful. My wife said if Apple were to make an easy bake oven, well, this is probably what it would look like. What's the print quality like? I can't believe the prints that come off of this machine. Check out some of these prints. Like this here is an exhaust flange for this printer, which I'll talk about later, but this is beautiful. This is printed with their Bambu Lab PETG carbon fiber, and it's just gorgeous. The layer lines, you can barely see them. It's beautiful. And I modeled this myself, actually. It's really nice. This here, and I got a couple of these are like coasters that I printed off. Yeah, this one here I designed, and I was able to use their software to color it in, to do the multi-color prints. This toolkit here, I grabbed this off of their website, the Maker, I forget what it's called, but the Maker Space or Maker something website for Bambu. And it holds all the additional parts that came with this printer. And this is a multicolor print, and it came out really nice. Although I don't like the glue stick that I used for it, which I'll talk about soon enough. This is a lithophane that I printed, and normally this would take like hours and hours, and it only took 2 hours on this printer. My other printers, it would take well over 6, maybe even 7, 8 hours. Some surfboard fins. Like this surfboard fin here is printed in nylon carbon fiber, and it is a beautiful. Like this looks like an injection molded print, or injection molded part, I should say. Not to mention about all the reviews out there raving about the print speed due to the input shaping. Honestly, I have no idea how that works, but it just works, which is something I can appreciate. I just want the printer to work and not to fuss with it a bunch. The print head moves so fast that it looks like a time lapse when compared to my other printers. So yeah, I've moved past the hobby stage of 3D printing that involves tinkering with the printers, say on like the Ender 3, which is my one way back there. I just want to be able to send something to the printer and for it to just print. Kind of like, you know, the Star Trek replicator. Now don't get me wrong, you still need to understand a few things about 3D printing, like print speeds, what filaments you should use for the particular application of the part. But the Bambu Slicer software does most of those settings and things like that for you, and it does it really well. Also, when you pause a print, it'll go back and inspect the layer with LiDAR before resuming the print, presumably to check for issues, and it will probably let you know. I didn't have any issues. Now, I was using this cool plate. Yeah, this one here, Bambu Cool Plate, and I just switched over to a PEI print sheet that I had on my Anycubic Viper because I didn't have the official one from Bambu yet. From what I understand, the PEI may not play nice with the LiDAR used for the first layer inspection and you know, the flow rate inspection. In terms of like the tolerances of this printer, I printed this here like I did with some of my other reviews. The Maker Muse's clearance castle, and it passed with flying colors. The bridging is really good, and nothing was welded together. Everything could come apart, and yeah, it passed, no problem. So let's talk about the Bambu Lab ecosystem. I think it's analogous to, say, Apple and their kind of ecosystem. I say that because you're dependent on like an internet connection and their apps if you want to monitor or control your prints with your phone or computer. Now, even though the Bambu Slicer is open source based on Prusa Slicer, you still need to be logged into Bambu's user service to use all the connectivity. Now, I know that there is a LAN mode as well, but I personally haven't tried it. But to be honest, coming from having to slice and then upload my prints using Octoprint and doing it separately and not having the webcam work all the time to monitor my prints or having to mess with Octopi and its updates, what I really appreciate is the Bambu ecosystem out of the box just works. Now don't get me wrong, I've been using Octoprint for years and it's freaking awesome, open source. I really appreciate all the work that has been done on it, but it is an extra item to manage. Now, the built-in 1080p camera is really handy, but it would be nice if the interior of the printer was lit a little better, because the time lapses, they look okay, but you know, it'd be nice if there was just a little bit better lighting. Now, the spaghetti detection, speaking of the camera, works well. I only had one print come loose and it paused the print and it notified me. I got a notification, it said, hey, something's up. So that is also a nice benefit of the cloud-based ecosystem. You get notification when prints finish or if there's an issue with something. All right, let's talk about the AMS system. It works really well and it allows you to print up to 4 distinct colors, or you can add additional AMSs and expand it. I think like up to maybe 16 colors, but don't quote me on that, I could be wrong. This is an awesome unit and it's a great feature, but I probably won't use it a ton except for doing, say, some stuff like lettering here on this coaster I made, like inset stuff like that. Just for like maybe if I want some lettering on top of a part that I print, because it does take a lot of time when you do multicolor printing. These coasters I printed came out beautifully, and the painting feature in Bambu Studio works really well, so you can just paint the areas of the model that you want in different colors. Where the AMS truly really shines is having a bunch of my most commonly used filaments already loaded and ready to print. No changing, they're there. The machine will change them all for you. It's not heated, but it does have a spot for desiccants to keep things dry, so that's good. There is a filament backup feature, so you never run out of filament during a print. And as long as the setting is turned on and a similar roll of filament is loaded in the AMS, it will automatically switch to that roll. And in my opinion, that feature alone is worth it for the AMS. No more messing around of having to like catch a print before it runs out of filament. It's so much easier. It's so good. With the complexity of the AMS, because there's a lot of PAHT-CF tubes running everywhere, especially if you have more than one. In this system, I've only had one jam using the AMS so far, so I can't speak to how easy it is to fix something if something like majorly gets jammed up. The other thing is that it still has the pressed-in bearings that Maker's Muse pointed out that can be problematic, are still in the version that I have, and Angus's videos from like, I think the spring or maybe winter. Hopefully I won't have any issues, but time will tell. I've only been using this printer for a couple weeks. Also, they recommend not running any of the like abrasive materials through it as it can wear down the internals. They say that, you know, their Bambu branded filament with like carbon fiber is okay to use through it, but I'm going to just use the external spool holder just in case, even with their own branded filament. If you use Bambu branded filament, there is an RFID tag on each roll which gets scanned, so you don't have to manually specify in Bambu Studio or on the printer itself or in the app to select the correct profile, you know, such as like things like type, the color, and the temperature. Also, if you're using their filament, it also keeps track of how much filament is left on the roll, and it actually shows you in Bambu Studio, kind of like a gas tank, which is kind of neat. Now, one thing about the AMS, it doesn't play nice with some of these cardboard spools. Printed some of these like adapters, like I have on this roll here, this, I guess, adapter ring for it. And I think the issue is the cardboard can flake up and jam things after, you know, it being rolled on the rollers for quite some time. I think that's the reason why the AMS doesn't play nice with it. So where the X1C is supposed to shine is it's really meant for printing engineering materials. I'm specifically interested in printing nylon and some common higher temperature materials like ASA. The enclosed printer allows for the printing of higher temperature filaments, and it has an exhaust out the rear of the printer that I can attach a venting hose that I have right now venting outside. So I've printed ABS, ASA, and no smell. It just exhausts it all outside, which is a must. Yeah, you probably don't want it just venting into the air. It comes stock with a high temperature hardened steel nozzle hot end for printing abrasive materials, and it looks something like that. And I actually purchased a slightly bigger one, a 0.6, because they say for printing more abrasive materials you should have something bigger. The printer comes with 2.4 nozzles. I went and purchased and ordered a 0.6 myself just to have on hand. So far, I have experimented with carbon fiber PETG, which are these prints right here, like this guy here, exhaust port. These surfboard fins, these are carbon fiber PETG as well. And I've actually stress tested these, and these are pretty tough. They're really good for PETG and carbon fiber. Definitely a lot stronger than just normal PETG. And PETG is pretty flexible, like, well, I would say flexible, it's pretty tough, but the carbon fiber gives it an extra edge. These were also printed on just the regular engineering plate. I also switched to using this liquid bed interface stuff, this, what's it called, Magigoo. This 3D printing adhesive. It works so much better than like using glue stick, just for the convenience. Glue stick is just messy, it's gooey, I don't like it. Now I have printed some functional parts, such as these surfboard handles. I was using my Creality S1 Pro in an enclosure, but I had so many issues with bed adhesion issues, because I'm printing at 100% infill for these, because these are going to be subjected to salt water, the elements. I do not want these failing in a surfboard. So what's happening is the temperature differential between the handle itself cooling and the bed temperature and the enclosure temperature not being, I think, hot enough causes it to lift off. Like for instance, here's one done in an orange ASA, and it's even still got the blue painter's tape on it. I was trying everything to get it to stick. Whereas this one here, coming right off the X1C, is beautiful. It's ready for use. It's perfect. Whereas this one, I didn't even take off all the support material. It just warped like crazy. You can just see the difference. And same with some of these older ones here as well. This one was done with Kapton tape, so it's got a smooth bottom. But again, it's got some bowiness to it. What I really think is, I'm pretty sure the issue mainly for that was the enclosure was too big and it wasn't getting to a hot enough ambient enclosure temperature. These exact same models off the X1C, as I said, these just, they came out perfect. They're just awesome. I'm so happy, saved me so much time. When I was messing with that, I was using like ASA cement, I was using glue stick, I tried tape, I tried everything. I even tried the Magoo. It just didn't work as good as this. Now these here are carbon fiber fins, nylon carbon fiber fins using the PAHT-CF that Bambu Lab sells. This is expensive stuff, but boy oh boy, it's beautiful. The finish is outstanding. They are tough. I am surprised. I've already whacked, I think this one here, this is just a smaller one. I already whacked this one with a hammer, just doing some testing earlier. And as you saw at the beginning of the video, I was like whacking on one of them. Like, I can't believe how tough these are. Now, I do think that once these are exposed to water, I think nylon has a tendency to absorb water. They might get a little bit maybe bendier, but that actually means it might be stronger, but for surfing, you probably want something a little bit stiff. We'll see how these handle over time. But anyways, this was my first time printing nylon as well. And the only changes I made to the default profiles was I had to slow the speeds down to around 100 millimeters a second. And even at that speed, it's still faster than any of my other printers printing, when at their fastest speeds. I think the higher temperatures that are needed to print nylon makes the layer adhesion so much better, which also makes for a stronger print than, say, some of other filaments. PLA for surfboard fins is completely terrible. Don't even bother. You're just going to pollute the ocean with broken fins. That's at least my theory about nylon and for surfboard fins. It's just a really durable material, and we'll see how it goes. Also, I'll mention that I did have to dry the nylon with my food dehydrator because my filament dryer, it actually doesn't reach a hot enough temperature. It only reaches 55 C, and I didn't want to use the drying feature built into the X1C since it ties up the printer and I wanted to do some printing. But once I did get the filament dried, the nylon, I did put it in the dry box and I kept it set to a temperature of 55 C while it was printing. I did have issues printing nylon fins laying down flat because of the warping forces. My first attempt, it actually lifted and pulled off the print bed. Next time I reprinted with it standing straight upward and had no issues, even though it might not be as strong of a print in the upright orientation because the layer lines are running like this. But as you can see from my not so scientific test of whacking the fin with a big hammer, they are very strong. Also, I had to film that shot several times, so this wasn't just, a one-off. I think I might have hit that fin at least 24 times. Already, I am stoked at how well this printer works for materials other than PLA, and I also printed a fin in polycarbonate, and it came out awesome until I whacked it with a hammer with my hammer test. I think some optimization is needed when printing in polycarbonate, and I don't think it's going to be a suitable material for 3D printing surfboard fins. In terms of things that I think could be improved is I wish it came stock with the PEI print bed. I actually have it installed in there right now. Even though this is aimed for people to print engineering materials, that's what it's marketed as, using the cool plate and glue stick for a PLA print, that's just really bothersome. And I can't be like bothered to wash glue stick off my prints. Just using the PEI plate is just so much handier. I have all my printers switched to that. Bambu did send me this PEI print bed and the high temperature plate. It just looks very similar to the engineering plate. Can't really tell the difference. But it would be nice for the cost of this printer to include both of these print beds, you know, or at the very minimum, like include the PEI bed, because you know a lot of people will probably still use the printer to print PLA, even if it is meant for engineering material, at least for consumers anyways, you know, household people. I wish the AMS bearing issue was fixed as well, or maybe it is, but mine still looks like it's pressed in, as I mentioned earlier, but I hope they're really working on a fix. I heard other reviewers say that it makes a lot of filament poop, and even though I'm not doing much multicolor printing, well, it makes a ton of poop. Like, this is just from a couple days of printing, and I wasn't really doing a ton of color printing. But every time it does like a filament change, purge, everything it does, there's just all kinds of this. My wife said something else funny besides the easy bake oven comment. She said that the printer looks like it's designed by Apple. Fit and finish is beautiful. Everything about it looks premium, but it doesn't sound like it. I had this set up in the kitchen for a little while when I first got it running, but it makes some really funny sounds when it's running and doing its pre-printing routines. But I wanted to mention that because you don't want this printing in a bedroom or a living space, as the printer is pretty loud, and when it's printing at its crazy fast speeds, it's not quiet. When it cleans the nozzle, you know, it sounds like it's smashing into the side or, you know, of the printer or doing something. Anyway, it's loud. Now, it would be nice if the nozzle was replaceable. Like I said, it does come with that spare nozzle or hot end unit here. I do find having to replace the whole nozzle assembly kind of strange, whereas I see on AliExpress has complete hot ends with replaceable nozzles. So I ordered one and I'm going to check it out, but it's going to take obviously a couple weeks to get to me. If it is definitely on the slow boat from China. The prices directly from Bambu are good, but you know what? I just like having more options. I don't use the LiDAR flow calibration much. At first I was using it a bunch, but I found it didn't make a huge difference and it added a few minutes to the print time. The LiDAR is neat because it inspects the flow rate and can inspect your first layer for errors. I may use it if I have troublesome prints. And as I said, if you resume a paused print, it inspects it. The color display is awesome. At first, I thought I wouldn't notice it much. I didn't think it would be a big deal having like a nice color display, but you know what? Having a nice color display, turns out it makes a difference. I really like it. The other thing is there is an SD card slot, and you need to have an SD card inserted if you want to record any time lapses as well. You know, the ability to monitor and control prints from my smartphone is awesome right out of the box. No configuring like with Octoprint. I even have the notifications turned on for my smartwatch. A few minor things with the AMS resting on the top of the printer. You can't access this top plate and open it easily. You have to disconnect the AMS tube and the cable in order to move it and, you know, remove the whole unit. The bed leveling is using a strain gauge, which I think is much nicer than using a probe like BL Touch. It does it all for you. There's no messing around with setting the Z height or anything like that. Tell it to level the bed and it does it all for you. So, is this printer any good? Yes, it is. In fact, it has blown away my expectations. My friend was totally right. I'm so happy he told me to go check out these printers. It's like easy to use, and honestly, I think that this 3D printer could be for the masses, or one of its variants like the P1P or the P1S, and even like the recently released Mini. Now, out of the box, it just works with no tinkering. It removes all the tinkering from the equation. Although there is a healthy community out there for this printer that is making mods and general life improvements, which is a good thing. if you do run into an issue, there is a large enough user base that someone else probably has come across that issue, whatever issue you are having. What intrigues me the most about this printer is it's touted as a printer for printing engineering materials. I'm going to be using this to print nylon for different applications. My interest is in 3D printing surfboard fins that are actually durable for real-world use and for long-term use. So I may do a video about that depending on how successful I am at printing fins. I've been doing it with my other printers, but again, with varying degrees of success. Usually PAHT-CF has worked really well, because where this really will shine is being able to model and then print a fin to see how it works is a good use case for rapid prototyping and 3D printing. So ultimately, who would I recommend this printer for? Probably makers or professionals who don't want to tinker and mess around with print settings. For the serious hobbyist, this is an amazing printer, but honestly, if I were to shell out my own money, I would probably buy the P1S or the P1P and spend the difference in the cost on filaments and accessories. In Canada, this printer is serious money, at least for a hobbyist. In my opinion, worth it, but it really, really depends on your application. If you need to print nylon or those engineering materials, then yes. If not, probably one of those other variants. And you know others are going to be copying Bambu. The 3D printing space is going to get interesting again finally, instead of just more and more ender freeze, but with slightly different features hitting the market. I hope you enjoyed this video and you learned something. I will see you guys in another one.